Today we are adding mixed numbers. These numbers are called mixed numbers because they are mixed whole numbers and fractions. Now this problem is pretty easy because our denominators are already the same. They're both 3. Let's use these math manipulatives found on My Math to help us illustrate. I'll grab one whole circle and another one for the 2 wholes and a third. For this side, I need 1 whole and 1/3. Now I'm adding, so I'll put them all together. Let's put these thirds by each other. Whoa! Rotate them around. You can see how this was an easier problem. Altogether, I have 3 whole circles and 2 1/3 circles. I would write my answer like this: equals 3 whole circles and 2 thirds. 2/3 cannot be simplified anymore, so this is our final answer, 3 2/3. We have a more challenging problem because we do not have the same denominator. Here we have eighths and over here a half. Let's start by illustrating this problem. Let me grab a circle. And I'm going to use this fraction circle container to help me organize my eighths. I need 7 of them. 1, 2, 3, 4, 5, 6, 7/8. Over here I have 1 1/2. Let's grab 1 1/2. Now in order to finish this problem, I'm going to need to change one of these fractions so that they'll have the same denominator. Maybe I need to change both fractions. So I'll have to think, what would be a good denominator both of these fractions can agree upon? I think it would be easy to keep the 7/8 the same and just change the half to eighths. So let's use this fraction circle container again. See how many eighths will equal a half. 1, 2, 3. Oh, get it up there, come on. There. It took 4/8 to make a half, which makes sense because 4 is half of 8. So instead of having this half, I'm going to delete it, and I'm going to use this half, or 4/8. Oops, keep that there. I just wanted to move it down here. So up here, I'm going to change my fraction. Instead of having 1/2, I'm going to change it to 4/8. And now I don't have this half anymore. I have 4/8. Now time to add them up. Well, easily I can see I have 2 wholes. When I get to the eighths, what I want to do is take one of these eighths, put it over here. So now I have 1 whole. So now I have 3 wholes altogether with 3/8 left over. So I shall write as my answer 3 big whole numbers and 3 little eighths left over. If I did not use manipulatives to figure this out, and I just used math, I would think to myself, well, 1 plus 1 makes 2 wholes, and then 7/8 plus 4/8, well, that would make 11/8. But do you see a problem with this being our final answer? This right here is an improper fraction. the number on top, the numerator, should not be larger than the denominator. So I need to turn it into a more simplified mixed number. I could tell myself, well, I know if I had 8/8, that would make another whole. So I could pull 8/8 out of 11/8, and that's how I would make another whole, and I would have 3/8 left over. Stop the video, put it on pause, try a few mixed number problems yourself. Go to page 673 of your math book and work out problems 2, 4, and 6. They give you a blank image of circles and fractions that you can color with your pencil if you want to. Pull out some colored pencils. And you can use this visual to help you find the answers to these math problems. When you get back, Smash might be here.
Hey Smash, will you help me with this next math problem? Okay. Wait, first I want to move it around. I'm going to put this underneath. And this plus. Like that. Oh, I like what you've done there. Yes, putting it vertical instead of horizontal. Well, we have 1 1/3 and 1 1/2 that we want to add up. Let's use these little strips, fraction strips, to help us add. Yes, earlier you were using circles. Circles makes me think of pie. Oh, that does sound delicious right now. But this time we will use fraction strips. Do they make you think of anything? Candy bars. I'm very hungry right now. Oh, I promise. We will definitely have dinner and then maybe a dessert after. Let's get through this math problem first, though. Okay. So we have 1/3 and 1/2. They do not have the same denominator. And we need to get them to have the same denominator. So let's find out what are some equivalent fractions that use the least common multiple of 3 and 2 to create that fraction that'll be easier for us to add. What if we use 6? Because 3/6 equal 1/2. And up here, we could use 2/6. That equals 1/3. For the fractions, we would write to the side 6. To transform the 2 into a 6, we'd be multiplying by 3. And whatever you do to the bottom, you must do to the top. So we will have 3/6 here, and up here we'll multiply by 2. 3 times 2 is 6. 1 times 2 is 2. 2/6. Great. Now that we have the same denominator, it'll be much easier for us to add up. We can add up the whole numbers, and then we can add up 2/6 plus 3/6. Smash, what will we get? Ah, yes, 2 5/6. Great. Now can we have a treat? Please. Okay, right after dinner. Promise, all right? Okay.
I'd like to show another way to write your math problems. I personally like to orient my addition problems going vertically like this instead of horizontally, probably because we've been writing addition problems like this since kindergarten. So I like putting them one on top of the other. Then I have this space over here to the side where I can write equivalent fractions if I need to, and in this case I will need to, because the denominator is not the same. We've got a 12 and we've got a 3. So I have to tell myself what would be a good denominator for both of these fractions. And I think 12 is a multiple of 3. So what if I leave the 11/12ths how it is, and I change 2/3 into 12ths? Let me get ready with my pen. Here to the side, I'm going to write out my new fraction with 12ths as the denominator. Now, how did I change a 3 into 12? I multiplied by 4. Here's my tiny, oh, that does not look like a multiplication, but I think you know what I'm saying. Times it by 4. I'll do better in the top because whatever we do to the bottom, we have to do to the top. Yeah, that's a better multiplication sign. So 3 times 4 equals 12. 2 times 4 will make 8. Now it'll be much easier to add these up. What's 11 twelfths plus 8 twelfths? 19 twelfths. 19 twelfths. And let me add up my whole numbers. 16 plus 5 is 21. Now, as I've said on an earlier problem, we cannot have the numerator be larger than the denominator. This is an improper fraction. To change this, I am going to take 12 twelfths out. That makes another whole. That means I will have a total of 22 whole numbers. And if I take 12 twelfths out, what do I have left? 19 subtract 12 is 7? I think so. 7 twelfths. 7 twelfths is already simplified, so this is my final answer. 22 and 7 twelfths.
Smash! Time for dinner!
Oh,